We still use ray tracing for this, and so there's going to be a lot of nice carryover. And these are the three rays that we can draw, and it'd be good to write these out. We have the principal ray, we have the focal ray, and we have the center ray. So the principal ray, we go parallel, then we go through the focus. The focal ray goes through the focal length, not the focus, goes through the focal length on the left-hand side, and then goes out parallel. And then we have the center ray, which passes straight through the center and keeps on going. And similar to what we had before, we really only need 2 out of the 3 rays. And you'll see that here as we move forward. The equations are the same, and that's really nice as mirrors. 1 over di plus 1 over d over equals 1 over the focal length. Magnification is hi over ho, and negative di over do. So all the same, but there's some critical things that we have to establish moving forward because it's really easy to get mirrors and lenses mixed up. One of the critical things here is that DO is always positive. So here's your lens, and the object's located over here, and this is the positive side. Well, it's located on the left-hand side, but the rays are coming from it, but DO, even though the object is on the left-hand side, DO is positive, even though it is on the left-hand side. And so distance of an object can't be negative unless you're dealing with combination lenses. And so that's another really critical thing. So the first critical thing was that the focus is positive for convex, for converging lenses, and then also DO is always positive for lenses, any lens. All right, so let's see if we can draw what this would look like on the other side of this lens. So if we had an object that's located greater than 2 focal lengths out, what would that look like? And so if you want to get your straight edge, I'm gonna walk you through this one step by step. Take your straight edge, and what you're going to do is align it up and then draw a parallel line that goes straight from the top here to the middle of the lens. Even though it's going to refract twice here, it's just easier to go straight to the middle, and then you're going to go through the focus. So straight across and then through the focus. And this is the parallel ray. Now we can draw the focal ray. The center ray. The center ray just goes straight through the center. The light coming from the tip of this would just go straight through the center and straight through like that. And then the focal ray goes straight through the focus and then comes out parallel. And then all 3 converge at this spot, and that's where the image will show up. So let's say we're over here, looking at, see, this is our eyeball. It's kind of nasty. All right, this is our eyeball. We're looking at the object. It would look like this, and it would be real, inverted, and reduced. And that's what it would look like on the other side of this lens. That's what that lens is doing to it. All right, so I'm going to have you try this one, and it'd be good to do all 3 rays to practice. So yeah, go ahead and pause the clip and take your straight edge and draw this one out on M22, and when you're ready to check, you can hit play to continue. All right, so here's the parallel ray through the focus, center ray, and then our image would show up here. We could do a focal ray, which would come down here and then straight out, and the image shows up there. And so in this case here, it's going to be real, inverted, and true. It's the same size. It's real because it's on the positive side, and it's inverted. It's not upright. All right, so let's try this one on M23. You can place your object in between 2 focal lengths and a focal length, and give this one a try. So yeah, go ahead and pause the clip and try this one, and when you're ready to check, you can hit play to continue. All right, so for this one, parallel ray, then through the focus, and then we've got our center ray, and then we could do the focal ray as well, come down and then come straight out across, and our object shows up here. So let's go ahead and name our image. We know it's real, it's on the positive side, it's inverted, and it is enlarged. This one is larger than the original, and so if we're over here and this is our eyeball and we're looking at this, that's what it's going to look like. It's going to be inverted, real inverted and large. All right, let's try one over the focus. Is M24. So yeah, go ahead and try this one. You can pause the clip, and when you're ready to check, you can hit play to continue. Okay, so parallel ray through the focus, center ray. Turns out there is no image formed when you have an object over the focal length, and yeah, very similar to what happens with a mirror on a concave mirror. There's no image formed. It's just, you know, confusion. You have light that's coming through. It just doesn't make any sense. Okay, so let's try this one. In between the focus and the focal length, rather, because we know this is the focus, right? It's critical. It's on the right-hand side. This is just the focal length. And so yeah, go ahead and pause the clip. Give this one a try. We'll warn you, this one's going to be kind of strange, but you probably should be able to figure it out what to do based on patterns from where we've gone. So yeah, go ahead and pause the clip. Give this a try. And when you're ready to check, you can hit play to continue. All right, so we have our parallel ray. We have our center ray, and we see that these rays are diverging, and we can trace the diverging rays backwards, and we end up with a image back here. And so it is on the negative side, so it is a virtual image. It is upright and it is enlarged, and that's what we get when we have an object that's in between the focal length and the convex lens. We get a virtual upright enlarged image. So if we're actually over here and we're looking at it, that's what it'll look like. It will be larger and appear to be a larger than the original there. This is kind of a neat picture here where a couple droplets are the shape of a convex lens, and so you can see how the text is inside the focal length, and therefore it is it's virtual, upright, and enlarged. And you can see that that effect there. Magnifying glasses work this way. They are convex lenses, and you put the object within the focal length, and it magnifies it. All right, so on this one, we're going to be able to draw as well as calculate and name. And so because you know the mirror equations already, you know, the 1 over di plus 1 over do equals 1 over the focal length, and magnification equals negative di over do, and magnification is hi over ho. You should be able to calculate the distance of the image, also the height of the image, and well, you're gonna have to get magnification first and then the height of the image. So yeah, go ahead and draw first, and then second calculate, and then 3 name your image, and you can check when you're ready. So go ahead and pause the clip, and when you're ready you can hit play to continue. All right, so we should have our first ray, parallel ray, and then through the focus, and then we'll have the center ray. You could draw the focal ray, then it comes out parallel, and our image should show up here. So our which should be real. It's on the positive side, it's real, inverted, enlarged. For the calculation, we should get a distance of 120 centimeters out there, and a magnification of -2, which makes the height -30. So when we, you know, evaluate where this is in location to where we started, the object started at 60 and it ended up way out here at 120, and it was twice as big. And yeah, there we go. So should be, yeah, should hopefully you know, see that now and be all set with that. All right, so one of the things for converging lenses, which are convex lenses, is critical. Focal length is positive, DO is positive, and DI is going to be, you know, just depending on how far away you are, and you don't need to memorize these last 2 bullet points because you could draw them out.